So the last cycle that we're going to look at is going to be the nitrogen cycle. You were to read the water cycle on your own. So let's talk a little bit about why your body needs nitrogen. So nitrogen is actually one of the most important nutrients in your body. It does almost anything in your body. So it helps to build your DNA. It makes up your muscles. Nitrogen is found in soil. Nitrogen is found in lots of medicines as well too. So nitrogen is really important. If we look at the atmosphere is actually 70% nitrogen, and the rest is made up of other gases, oxygen, argon, carbon dioxide. So when you take a deep breath in, most people think you're breathing in oxygen. You're actually breathing in very little oxygen. You're mostly breathing in nitrogen. There's lots of different forms of nitrogen in the environment. These are all examples of nitrogen that you might see and where they might be found. So you've got nitrogen gas. We looked at this a little bit in chemistry. You've got ammonium, we have ammonia, nitrate, and we've got nitrite. Most of these are found in the soil. So the last three are found in the soil. Ammonium is found in waste products, and then nitrogen gas is found in the atmosphere. So if you take a look, even though 70% of what you breathe in is nitrogen gas, it is not usable. We cannot actually use it. Neither plants or animals can use that nitrogen. If you take a look at this list, the only one that humans can use is nitrates and nitrites. So humans can use both nitrates and nitrites, as can plants. Neither plants or humans can use ammonia, and humans can't use ammonium, but plants are able to. So if you take a look, there's actually very limited usable nitrogen that humans have. So this is where the nitrogen cycle is going to come in. So in the nitrogen cycle, we're moving nitrogen from one form to another form. Humans can't absorb nitrogen ourselves, but plants can. So many of the nitrogen sources that we get actually comes from our food. So it's really important that you eat your veggies. Let's take a look at how we actually make usable nitrogen. So the process of creating nitrogen that humans can use is called nitrogen fixation. So essentially, we're going to take that atmospheric nitrogen that we can't use, and we're going to use it, turn it into forms that can be used. So ammonia, nitrate, or nitrite. There's two different ways that you can do that. The first and most dramatic way is lightning. So we studied lightning last unit. Whenever lightning strikes, it actually has enough energy that it takes that atmospheric and nitrogen and it turns it into usable nitrogen. The other way that we can get nitrogen is through bacteria. So that's a symbiotic relationship that we have. Bacteria can actually take this nitrogen we can't use and fix it into nitrogen that we can use. On the other hand, we have this process called denitrification. Denitrification is taking that usable nitrogen that we have and turning it back into that atmospheric nitrogen. So it takes that usable nitrogen, it turns it back into that unusable nitrogen, and this happens using bacteria. A couple of significant steps in the nitrogen cycle. So we're going to look at the nitrogen cycle next. A couple different steps that you're going to see that I want to point out here. There's a step called ammonification. Here we're going to take dead plants and animals waste, and we're going to convert it to NH4 using decomposers. So we're going to take those dead plants and animals or animal waste, and we're converting it into NH4 ammonium using decomposers. Nitrification is the process of ammonia to nitrate by bacteria. So we're going to take that ammonia, that NH3, we're going to turn it to nitrate, NO3, using bacteria. And then there's also this step called assimilation. Assimilation is plants are going to absorb either that nitrate or that ammonium by root hairs, and they're going to take it into their system. So these are three different steps in the nitrogen cycle, and we want to keep a lookout for them when we take a look at the diagram. So let's go ahead and take a look at how nitrogen is going to move through the ecosystem. So it's just like the carbon cycle, just a little bit more complicated. So we have that atmospheric nitrogen up here. Remember, we can't use this. That's that N2. So it's going to be fixated. One way it can be fixated is using that lightning. So another way it can be fixated is using that bacteria. So either lightning or bacteria is going to fix that nitrogen into a form that maybe we can use. So it's going to fix it into NH3, and then other bacteria is going to come along and it's going to turn it into NO2. This is that nitrification process. This NO2 is then going to get changed into NO3, and this NO3 can actually be used. So this nitrate can be assimilated into plants. It can be assimilated into grass, or using bacteria, it can actually be put back into the environment. So going from this usable nitrogen to this unusable nitrogen, we call this denitrification. One other step over here is that idea of animal waste. So animal waste can actually be turned into usable nitrogen. We call that ammonification. So that's taking that animal waste, that NH4, it's going to convert it into NO2, and then we can turn it into that NO3. So you can actually see us cycling between our unusable nitrogen up here to our usable nitrogen down here. That's called the nitrogen cycle. A couple different things that we do can impact the nitrogen cycle. So these are the human impacts on the nitrogen cycle. Oftentimes, excess fertilizer use and animal waste can end up in the runoff. So if we use animal waste in farming or fertilizer, it often ends up in runoff and in groundwater. Too much nitrogen can actually kill an area. So if you've used too much fertilizer at home, it can kill your grass. Burning fossil fuels also emit excess nitrogen, so you're releasing nitrogen gas and other nitrates into the atmosphere, and you're contributing to the nitrogen cycle that way. So again, the nitrogen cycle is a balance, it's a cycle, and we don't want to impact it by using fertilizer or fossil fuels because it might throw off that balance.